60,000 light-years away from the warmth of our solar system, resting in the outer halo of the Milky Way, the environment is defined by a deep and suffocating stillness. Out here, the interstellar medium is little more than a freezing ocean of sparse hydrogen and trace dust, suspended in a vacuum where ambient temperatures hover just fractions of a degree above absolute zero. Gas clouds larger than our entire planetary system drift at a glacial, agonizingly slow pace. It is a region of the galaxy that has remained largely undisturbed for billions of years, a quiet graveyard of primordial matter waiting for a gravitational trigger that may never arrive. But a recent stream of raw telemetry beamed back to Earth has proven that this ancient silence has been violently ruptured. The data was captured by an aging cylinder of mirrors and sensors, falling endlessly in low Earth orbit, staring deep into the dark constellation of Columba. When astrophysicists began compiling the latest deep field exposures, they were not looking for an anomaly. They were simply cataloging the faint glow of distant ancient star clusters. Instead, the images returned with a massive, inexplicable physical scar carved directly through the darkness. It was not an error in the optics or a stray cosmic ray hitting the camera sensor. It was a tangible, linear contortion of space. Something of incomprehensible scale is currently tearing through that quiet ocean of gas. It is not moving with the gentle, predictable orbital mechanics of the surrounding stars. It is plowing through the galactic halo at a velocity that defies the natural gravitational limits of the region, traveling in excess of 4 million miles per hour. At this relentless pace, an object could cross the distance between the Earth and the Moon in roughly 3 minutes, or travel from the Sun to Neptune in a matter of days. The kinetic energy required to sustain this momentum is staggering, but the most unsettling detail hidden within the observational data is not the speed. It is the absolute absence of light. When an object of immense physical mass travels through a dense nebula at hypersonic velocities, the friction alone should ignite the surrounding hydrogen. It should blaze with a blinding plasma wake, pulse with violent electromagnetic radiation, or flood our sensors with high-energy X-rays. The telescope scanned every available spectrum, searching for the brilliant thermal signature of a hypervelocity star or the explosive remnant of a supernova. The readings came back entirely flat. Whatever is hurtling through that distant sector of space is completely invisible to every instrument we possess. We only know it is there because of the catastrophic violence of its wake. Like a silent ship cutting through a black ocean, this invisible mass is compressing the interstellar gas with such extreme gravitational force that it is triggering a shockwave of newborn stars in its path. This fiery trail of shocked plasma and infant suns stretches for over 200 light years, pointing like a glowing arrow directly back to the origin of the disturbance. The mathematics derived from this wake present a terrifying variable. To carve a trail of this magnitude, the invisible object leading the charge must possess a concentrated mass equivalent to 20 million of our suns. We are tracking a ghost of unfathomable power, wandering untethered and rogue in the dark. Our biological hardwiring demands that extreme power must announce itself with brilliant illumination. We evolved under a warm, yellow sun, and our neurological architecture was forged by the light of campfires, the flash of lightning, and the glow of burning forests. We intuitively associate energy with visibility, but this is a terrestrial bias, a profound sensory flaw born from living in a highly sheltered microscopic pocket of the cosmos. The universe operates under a different, far more ruthless economy. In the true mechanics of the void, light is merely incidental. It is a secondary emission, a trivial waste product of lesser, chaotic reactions. The true architect of reality, the force that commands the geometry of space and the destiny of galaxies, is mass. And mass does not need to shine to exert its dominance. When you decouple physical mass from luminosity, the universe transforms from a theater of shining stars into a predator's hunting ground. We are forced to investigate this galactic anomaly, not by what it radiates into our telescopes, but by the physical violence it inflicts upon its surroundings. We must track the invisible by the displacement of the medium it destroys. To understand the nature of this anomaly, we have to abandon the illusion that the space between the stars is completely empty. The interstellar medium is a highly attenuated fluid. It is a near vacuum, but it is laced with cold, diffuse hydrogen gas and microscopic silicates. When a physical object moves through this medium at normal stellar velocities, the gas simply flows around it, guided by gentle gravitational currents. But the entity tearing through the Columba constellation is not moving at a normal velocity, and it is not a normal mass. It is traveling at 4 million miles per hour. At this hypersonic regime, fluid dynamics are pushed to absolute extremes. The entity is moving faster than the speed of sound within the interstellar gas. It does not push the hydrogen gently aside. It violently rams into it, compressing the cold particles with staggering kinetic force. The mathematics describing this event are brutal and precise. As the invisible object plows through the halo, its immense gravity drags the surrounding gas inward, creating a funnel of localized density. This is known as dynamical friction. The gas is pulled into a turbulent wake behind the moving object, colliding with itself at astronomical speeds. The pressure within this wake spikes exponentially. The hydrogen is compressed so severely that it overcomes its own thermal resistance and collapses inward under its own weight. This extreme compression triggers sudden, rampant nuclear fusion. The object is literally forcing the cold, dead gas of the galactic halo to ignite. It is leaving a contrail of newborn burning stars in its wake. By analyzing the length of this stellar contrail, the specific heat of the plasma, and the sheer volume of gas required to birth these stars, astrophysicists can reverse engineer the equation to find the mass of the invisible object leading the charge. The kinetic transfer dictates that to warp the interstellar medium to this degree, to drag this much hydrogen into a collapsing wake, the unseen object must possess a concentrated mass of 20 million suns. This number is a localized mathematical terror. 20 million solar masses, compressed into a volume that emits absolutely zero thermal radiation, zero X-rays, and zero radio waves. The laws of thermodynamics, stellar evolution, and quantum mechanics leave only one physical reality that fits these parameters. It is a supermassive black hole, a singularity, a point in space where matter has been crushed to infinite density, wrapping the fabric of space-time around itself so tightly that not even light can escape its gravitational trench. But reaching this conclusion violently fractures our foundational understanding of galactic architecture. Supermassive black holes are not supposed to be wanderers. They are the deep gravitational anchors around which entire galaxies rotate. They reside at the absolute darkest center of the galactic potential well. The supermassive black hole at the center of our own Milky Way, Sagittarius A star, holds the central bulge of the galaxy in a delicate orbital balance. To find a singularity of this magnitude tearing through the outer halo, completely untethered from a galactic core, is a structural paradox. It is the equivalent of finding the concrete foundation of a skyscraper, flying untethered through the upper atmosphere. It defies the baseline logic of how mass behaves on a cosmic scale. What force in the known universe is capable of unmooring an anchor of this magnitude? What mechanism has the power to eject 20 million solar masses into the freezing void? The answer lies in the catastrophic, slow-motion violence of galactic collisions. When two galaxies merge, it is not a sudden, explosive crash. It is a tortuously slow gravitational seduction that plays out over hundreds of millions of years. The outer rims of the galaxies mesh like gears, stripping stars from their stable orbits and throwing them out into the intergalactic void like sparks from a grinding wheel. But the true, absolute violence is reserved for the cores. The supermassive black holes at the heart of each colliding galaxy are drawn inexorably toward one another, sinking heavily to the deepest point of the newly combined gravitational well. As they approach, they do not immediately collide and fuse. They enter a decaying binary orbit. They become a death spiral, circling each other at significant fractions of the speed of light. This is where classical physics collapses entirely, and Einstein's tensors of general relativity take absolute control. We are looking at two independent singularities, each possessing the mass of millions of suns, churning the vacuum of space. They become a cosmic engine. and the exhaust of this engine is not gas nor radiation, but gravitational waves. Gravitational waves are literal distortions in the geometry of space and time. They carry monumental amounts of energy away from the binary system, bleeding momentum from the black holes and forcing their orbits to tighten. The calculus of this binary dance describes a relentless, inescapable decay. For millions of years, they radiate this invisible space-bending energy until the distance between them closes to a mere fraction of a light year. The space surrounding them is twisted into a maelstrom of relativistic forces. Time itself dilates and warps under the strain, and then, in a fraction of a second, the event horizons intersect. If the two black holes were perfectly identical in mass and spinning at the exact same velocity, the merger would be a perfectly symmetrical implosion. The newly formed larger black hole would settle quietly into the center of the new galaxy. But the cosmos is rarely perfectly symmetrical. One singularity is almost always heavier, or spinning at a different chaotic angle. When this asymmetrical collision occurs, the emission of gravitational waves becomes severely lopsided in the final microsecond of the merger. A tsunami of gravitational energy is fired out in one specific direction. Because momentum must be conserved, the newly fused supermassive black hole is struck by an unfathomable amount of reactive energy in the exact opposite direction. This is a recoil effect, identical in physical concept to the kick of a fired rifle, but scaled up to a magnitude that breaks human comprehension. The physics dictate that this asymmetric gravitational kick can accelerate the singularity to velocities well beyond millions of miles per hour. It violently snaps the black hole out of its resting position. The kick is delivered not by physical impact, but by the violent, explosive snap of space-time restoring its own geometry. To escape a galaxy, an object must overcome the escape velocity of the entire galactic mass. For the Milky Way, that requires speeds of roughly 1.2 million miles per hour. The recoil of a supermassive black hole merger can generate kicks exceeding 3, 4, or even 5 million miles per hour. The singularity is launched like a silent, invisible artillery shell out of its own host galaxy, condemned to wander the freezing intergalactic abyss. Theoretical physicists have known about the mathematics of gravitational recoil for decades. The equations permitted it. Supercomputers simulated the massive energy releases, showing how singularities could be kicked out of their host galaxies. But theoretical math on a chalkboard is a very different beast from observational reality. For a long time, the consensus was that while these rogue supermassive black holes might exist, space is simply too vast, and they are too perfectly camouflaged to ever be found. They do not emit light, they do not reflect radar, they do not announce their approach. They are the ultimate apex predators of the void, perfectly adapted to the dark. The discovery of this stellar wake in the Columba constellation proves that the theories were not just mathematical curiosities. The universe is actively generating rogue singularities of incomprehensible scale, and they are out there, wandering the dark expanses between the stars. The realization that an object weighing 20 million suns can move completely undetected until it smashes through a nebula shatters our comforting illusions of cosmic safety. It forces us to acknowledge that our visual map of the universe is hopelessly incomplete, missing the invisible giants that roam the dark. If you seek to confront these uncompromising truths and understand the relentless physics of the cosmos, subscribe and join us as we continue to map the shadows. To fully grasp the magnitude of what is carving its way through the constellation of Columba, we must strip away our terrestrial understanding of size and distance. The human brain is engineered to navigate a world measured in miles and hours. We are biologically unequipped to visualize an object containing the mass of 20 million suns, compressed into a sphere smaller than the orbit of Mercury, traveling at 4 million miles per hour. We cannot picture a trail of newborn stars stretching across a distance so vast that light itself, traveling at 186,000 miles per second, requires 200 years to cross from one end to the other. To bridge this cognitive gap, we must examine the raw data gathered by our most precise orbital instruments and translate their digital telemetry into a physical reality. The primary evidence of this wandering singularity was not captured in a single fleeting glance. It required the sustained, unblinking gaze of the Hubble Space Telescope. Orbiting high above the distorting effects of the Earth's atmosphere, Hubble operates in a realm of absolute optical silence. It uses an intricate system of beryllium mirrors, polished to a molecular level of perfection, to catch individual photons that have been traveling through the freezing vacuum for millions of years. When astrophysicists directed Hubble's advanced camera for surveys toward the Columba constellation, the photons hitting the sensors did not register the chaotic, scattered light of a normal star field. Instead, the digital mosaic returned an anomalous, perfectly linear structure. In the chaotic environment of the universe, where orbits are elliptical and gas clouds are torn into irregular shapes by stellar winds, a perfectly straight line is a physical impossibility. Nature does not draw with a ruler. Straight lines require an overwhelming singular vector of kinetic energy that completely ignores the ambient gravitational currents of the surrounding environment. Yet, burning across the deep field image was a flawless streak of ionized oxygen and blistering ultraviolet radiation. This straight, glowing filament is the physical wake of the black hole. To understand how a completely invisible object leaves a blazing trail 200 light-years long, we must look at the mechanics of extreme thermal shock. The outer halo of the Milky Way is filled with an ancient, highly diffuse gas, predominantly composed of neutral hydrogen. This gas is incredibly cold, hovering in a state of thermal lethargy. The ambient pressure is so low that the atoms rarely interact. But when the 20 million solar mass singularity plows through this quiet medium at 4 million miles per hour, it introduces an unimaginable mechanical trauma. The physics governing this interaction are not based on radiation, but on the brutal reality of ram pressure. Imagine standing in an empty city street at dawn. The air is completely still. If a person walks past you, you feel nothing. If a car drives past at 60 miles per hour, you feel a sudden, violent displacement of wind. Now, imagine a solid wall of iron moving through that same street at Mach 50. The air cannot simply move out of the way. It is struck with such overwhelming kinetic force that it compresses instantly into a superheated wall of plasma. This is exactly what is happening in the galactic halo. The black hole is moving at hypersonic speeds relative to the speed of sound within the interstellar gas. As the invisible gravity well smashes into the cold hydrogen, the gas is violently swept up and crushed together. The temperature of the hydrogen spikes from near absolute zero to tens of thousands of degrees in an instant. This localized extreme heating strips the electrons from the hydrogen atoms, creating a churning, turbulent shockwave of glowing plasma. But the true architecture of this wake is revealed in what happens next. The shockwave does not simply dissipate into the void. Because the black hole is moving so fast, it leaves the compressed gas behind almost immediately. Once the singularity has passed, the immense localized pressure drops. The superheated plasma begins to cool rapidly in the freezing vacuum of space. As it cools, the thermodynamics of the gas flip. The compressed material loses its thermal energy, but it retains the incredible density forced upon it by the black hole's passing. The gas becomes so heavy and densely packed that its own internal gravity takes over. It begins to collapse inward on itself. Across the entire 200 light-year length of the wake, these collapsing pockets of dense gas ignite under the crushing pressure. Nuclear fusion initiates. The invisible giant is literally forcing the cold, dead gas of the halo to birth a continuous chain of massive, hyperactive stars. Through meticulous spectroscopic analysis, astronomers have dissected the light emitted from this stellar contrail. By separating the light into its constituent wavelengths, they can read the chemical fingerprints and the ages of the stars within the wake. The data confirms a chilling timeline. The stars at the furthest tip of the trail, the oldest point of the wake, are barely a few million years old. They are infants on a cosmic scale. But as the telescope pans along the line, following the trajectory back toward the source, the stars become progressively younger. And at the absolute leading edge of the structure, at the exact point where the linear streak abruptly ends, the spectroscopy detects the intense, chaotic chemical signature of ionized oxygen. This is the raw, burning edge of the shockwave. This is the exact location of the invisible impact. However, locating the leading edge of the shockwave presents scientists with a profound mechanical contradiction. A black hole of this monstrous magnitude, tearing through a dense field of gas, should not be invisible. We know that supermassive black holes at the centers of galaxies are some of the brightest objects in the known universe. They are quasars. Their immense gravity pulls in surrounding matter, trapping it in an accretion disk that swirls around the event horizon. As the matter spirals inward, friction heats the gas to millions of degrees, causing it to emit blinding floods of X-rays and visible light. A black hole dragging itself through a dense hydrogen nebula should be feeding voraciously. It should be ablaze with the light of a massive accretion disk. Yet, the apex of the shockwave in Columba is totally dark across every frequency of the electromagnetic spectrum. The Chandra X-ray Observatory, capable of detecting the faintest thermal whispers of black hole activity across the universe, stared deep into the leading edge of the wake. It found absolute zero. There is no accretion disk. There is no X-ray emission. There is nothing but the cold, invisible mathematics of a gravitational distortion. This complete absence of light reveals the most terrifying aspect of the anomaly's speed. The mathematics of black hole feeding, defined by the Bondi accretion rate, establish a strict relationship between an object's velocity and its ability to capture surrounding matter. If a black hole is stationary or moving slowly, its gravity has time to reach out, grab the surrounding gas, and pull it into a stable, glowing orbit. But at 4 million miles per hour, the physics of capture completely break down. The singularity is moving so fast that it outruns its own ability to hold onto the gas. The hydrogen particles are struck with such extreme kinetic velocity that they simply bypass the event horizon. The gravity of the black hole is immense, but the exposure time is too brief. Before the gas can be drawn into a fatal spiral toward the singularity, the black hole has already hurtled millions of miles away. It is like trying to catch falling rain in a teacup while driving a vehicle at supersonic speeds. The water simply shatters against the surface and is left behind. The supermassive black hole is trapped in a state of eternal starvation, dictated entirely by its own relentless momentum. It is a 20 million solar mass engine of destruction, carving a multi-million-year scar across the galaxy, entirely cloaked in darkness because it is moving too fast to light a fire. We are not just observing a physical object moving through space. We are looking at a localized breakdown of how energy and mass are supposed to interact. And as astrophysics attempts to model the future trajectory of this dark mass, tracking its ballistic path through the outer halo and beyond, the calculations begin to demand an answer to a much larger, far more dangerous question. If a merger in an ancient galaxy can generate enough recoil energy to launch 20 million solar masses into the void at 4 million miles per hour, the mathematics suggest this cannot be an isolated incident. The wake in Columba is merely the first one we have accidentally stumbled upon because the angle of its trajectory happened to catch the light of its own destruction. The underlying variables of galactic evolution, when fed into our supercomputers, reveal a structural flaw in the architecture of the cosmos. The mathematical models designed to predict the evolution of the cosmos are some of the most sophisticated architectures ever engineered by the human mind. They are fed with the fundamental constants of nature, the speed of light, the mass of the electron, and the rigid tensors of general relativity. When astrophysicists run these simulations on supercomputers, they can accurately fast-forward the universe, watching digital galaxies form, spin, and collide in perfect accordance with the laws of physics. But when these same supercomputers attempt to model the precise moment a supermassive black hole is violently ejected from a host galaxy, the system encounters a catastrophic mathematical wall. The equations do not simply struggle to find an answer, they crash. This failure is not a glitch in our software. It is a fundamental breakdown in our understanding of how the universe operates at its absolute extremes, known in astrophysics as the final parsec problem. To understand why the physics break down, we must trace the mechanical steps of a galactic collision. When two galaxies merge, their respective supermassive black holes do not instantly rush toward one another. The distances are too vast. Instead, they begin a tortuous descending orbit that takes hundreds of millions of years. As they circle each other, They plow through the dense core of the newly merging galaxy, which is packed with millions of stars. The black holes use these stars to shed their orbital momentum. Through a mechanism called dynamical friction, the gravity of the black holes grabs passing stars and violently slingshots them out into deep space. By transferring their kinetic energy to these ejected stars, the black holes act like braking engines, slowly bleeding away their speed and allowing gravity to pull them closer together. This process of gravitational slingshotting is highly efficient, shrinking the orbit from thousands of light-years down to a mere 3.2 light-years, a distance exactly equal to 1 parsec. But at this precise distance, the mechanics abruptly halt. The black holes have done their job too well. They have violently ejected every single star in their immediate vicinity, clearing a massive empty cavity in the center of the galaxy. There is no more gas, no more dust, and no more stars left to interact with. The fuel for their deceleration is gone. According to the strict laws of classical mechanics, the two singularities should now be stranded. Without any surrounding matter to absorb their momentum, they cannot bleed off any more energy. The math dictates that they should orbit one another in this empty cavity forever, locked in a perfectly stable, eternal standoff. They should never merge. Yet the raw telemetry from the Columba constellation shatters this mathematical certainty. The 200 light-year wake of burning stars is undeniable physical proof that an ejection occurred, which means a massive merger had to take place. The universe is crossing the final parsec, but it is doing so using a mechanism that is completely absent from our equations. We are observing the aftermath of a process we cannot calculate. Some theoretical physicists suggest that the deadlock is broken by the chaotic intrusion of a third massive black hole, introduced by a subsequent galactic collision. This creates a three-body problem, a notoriously unsolvable mathematical nightmare where the gravitational trajectories become so wildly unstable that one of the singularities is violently thrown out, forcing the remaining two to crash together. Others suggest that the sheer twisting pressure of dark matter funneling into the core forces the final collapse, but these are merely theoretical patches placed over a gaping hole in our foundational physics. When the barrier of the final parsec is finally breached by whatever dark mechanism the universe employs, the resulting merger triggers a secondary, far more profound breakdown of logic. As the two event horizons make contact, we are forced to observe the limits of human science. We have two incredibly successful frameworks for understanding reality. General relativity maps the macrocosm, explaining how massive objects warp the smooth, continuous fabric of space and time. Quantum mechanics governs the microcosm, describing a jittery, granular reality of subatomic particles and probability. In almost every scenario in the universe, these two rulebooks operate independently without interfering with one another. But at the exact epicenter of a supermassive black hole merger, both rulebooks are forced into the same infinitesimal space, and they violently reject one another. Inside the merging event horizons, millions of solar masses are compressed into a point of zero volume. When you input a zero volume into the equations of gravity, the resulting density is infinite. In mathematics, infinity is not a number, it is an error code. It is a giant red flag signaling that the theory has fundamentally failed. The equations of general relativity predict that space and time twist infinitely tight until they simply cease to exist. But quantum mechanics strictly forbids this, arguing that nothing can be compressed infinitely and that the underlying information of the universe can never be permanently destroyed or squeezed out of existence. The core of the merger becomes a paradox of pure logic, an impenetrable firewall where the known laws of nature shatter into meaningless contradictions. We are completely blind to the mechanics of the impact itself. We can only measure the terrifying recoil of its aftermath. The mathematics of the recoil rely on an absolute brutal lack of symmetry. The universe does not produce identical twins on a cosmic scale. When these two colossal singularities finally intersect, they are never perfectly matched. One black hole is invariably heavier than the other. Their axes of rotation are tilted at wild, chaotic angles, spinning like lopsided gyroscopes. As they fuse into a single massive entity, this severe physical imbalance wreaks havoc on the surrounding geometry of space. The energy of the collision is not released as a gentle, uniform sphere of radiation. Instead, it is converted entirely into gravitational waves, invisible ripples in the vacuum that carry the kinetic force of billions of exploding suns. Because of the extreme asymmetry of the merging masses, this tidal wave of space-bending energy is fired disproportionately in one specific direction. The basic laws of motion demand that every action has an equal and opposite reaction. When a massive blast of gravitational energy is focused in a single direction, the newly formed black hole must absorb the exact opposite kinetic force. The math reveals a merciless truth. The greater the imbalance between the two original black holes, the more violent the resulting kick. The entire combined mass, weighing tens of millions of suns, is struck by an invisible hammer forged of pure space-time. This is not an impact of matter against matter. It is reality itself violently snapping back into shape, transferring an unfathomable amount of momentum directly into the singularity. This mechanism creates a terrifying statistical reality. The history of the cosmos is 13.8 billion years deep, defined by an endless violent era of galactic cannibalism. Every major galaxy in the observable universe has undergone dozens, if not hundreds, of massive collisions. Our own Milky Way is currently tearing apart several smaller dwarf galaxies, and in a few billion years, it will suffer a catastrophic head-on collision with the Andromeda Galaxy. If the mathematics of asymmetric recoil are fundamentally correct, and the blazing wake in Columba proves that they are, then this ejection event is not a rare freak anomaly. It is a standard operational byproduct of galactic evolution. When we feed the conservative estimates of historical galactic mergers into our models, combined with the probability of asymmetrical spins, the resulting numbers generate an invisible population of staggering proportions. The math demands that the universe is teeming with these ejected masses. For every galaxy anchoring the visible light of the universe, there are likely thousands, potentially millions, of rogue, supermassive black holes that have been entirely decoupled from their host galaxies. They have been forcefully evicted, condemned to drift through the vast freezing expanses of the intergalactic void. This introduces the ultimate physical barrier. The intergalactic void is the closest thing to true emptiness in the natural world. The space between galaxies is so starved of matter that a rogue black hole could travel for 1 billion years without encountering a single stray atom of hydrogen gas. In this absolute vacuum, the singularity has nothing to consume. Without gas or dust to compress, it cannot generate an accretion disk. It cannot generate friction. It emits absolutely no light, no X-rays, and no radio signals. It becomes a perfect sphere of total darkness, a gravitational ghost, matching the exact ambient temperature of the deep freeze around it. We can only detect them if they happen to smash directly into a dense pocket of gas, like the anomaly we are currently tracking in the galactic halo. But the vast majority of these rogue masses will never hit a dense nebula. They will sail silently through the empty corridors between the galaxies, completely invisible to every optical, thermal and radio telescope ever constructed. We have mapped the glowing architecture of the universe, carefully cataloguing the burning stars and the swirling galaxies under the dangerous illusion that light equals mass. But the mathematics of the recoil confirm that the heaviest, most destructive engines in the cosmos have already left the illuminated cities. They are moving blindly through the dark, and we possess no instrument capable of seeing them coming. The realization that the universe is actively ejecting its most massive gravitational anchors forces a complete re-evaluation of our place within the cosmic architecture. We have historically viewed galaxies as the ultimate safe harbors of the universe. We observe them as majestic, glowing islands of order, spinning predictably in the dark. We take comfort in the steady rotation of the Milky Way, trusting that the central mass of Sagittarius A star will forever hold our solar system in a stable, predictable orbit. But the blazing wake in Columba dismantles this comforting illusion. It reveals that galaxies are not permanent sanctuaries. They are highly porous, temporary structures, prone to catastrophic internal fractures that bleed their heaviest components out into the freezing void. This forces us to confront a hidden reality. The empty space between the stars and the vast oceans of nothingness between the galaxies are not empty at all. They are populated by an invisible diaspora of exiled monsters. The immediate consequence of this invisible population is a profound destabilization of how we view cosmic risk. When we look up at the night sky, our primary existential fears are usually bound to things we can see or anticipate. We track the trajectories of near-Earth asteroids. We monitor the unstable, swelling masses of aging stars waiting to go supernova, and we measure the solar flares erupting from our own sun. These are localized threats, driven by light, heat, and physical impact. But a rogue supermassive black hole operates entirely outside this framework of visible danger. It does not need to physically strike a planet or swallow a star to annihilate a solar system. Its weapon is pure long-range gravitational distortion. Gravity is the only force in the universe that has an infinite reach. While its strength diminishes over distance, it never truly drops to zero. A singularity weighing 20 million solar masses casts a gravitational shadow that extends for light years in every direction. If one of these wandering leviathans were to drift through a populated sector of a galaxy, the destruction would not look like a sudden explosion. It would be a slow, silent, and mathematically inevitable unraveling of celestial mechanics. Imagine a rogue singularity passing through the outer edges of a stellar neighborhood, completely cloaked in darkness because it is moving too fast through the vacuum to generate an accretion disk. Long before the black hole reached the inner planets of any star system, its massive gravitational wave would wash over the outer orbital shells. In our solar system, this is the Oort cloud, a fragile, icy shell of billions of dormant comets resting at the very edge of the sun's gravitational grip. The passing of a supermassive black hole, even at a distance of several light years, would violently warp the delicate balance holding these comets in place. The gravitational tides would shear the Oort cloud apart, sending millions of massive ice bodies plunging inward toward the sun in a catastrophic, system-wide bombardment. But this is merely the opening tremor. As the invisible mass draws closer, the fundamental geometry of the local space-time begins to warp. The planetary orbits, which have remained stable for billions of years, rely on a delicate, perfectly balanced tug-of-war between their own forward momentum and the gravity of their host star. The introduction of a 20 million solar mass object completely shatters this equilibrium. The equations governing orbital mechanics become hopelessly chaotic. Planets are subjected to a massive asymmetrical pull that their host star cannot counter. Within a matter of years, gas giants would be ripped from their established lanes, their orbits stretched into extreme ellipses. Habitable worlds would be violently dragged out of the warm, temperate zones of their stars, either plunged into the freezing darkness of deep space or hurled inward to be incinerated. The entire solar system would be unspooled like a broken clock spring. And the most terrifying aspect of this apocalypse is its absolute silence. Because the black hole emits no light, no warning radiation, and no thermal signature, the inhabitants of a doomed world would never see their destroyer coming. They would only look up to see the stars shifting in the sky, the constellations warping as light itself bends around the approaching invisible mass. They would experience a sudden, inexplicable disruption of their tides, a fracturing of their planetary crust, and the cold realization that their world has been untethered from the sun. The destruction would be absolute, and the executioner would remain a complete ghost, passing back into the dark without leaving a single trace of its physical form, save for the ruined, scattered debris of a once stable system. While the statistical probability of a rogue singularity passing directly through our specific solar system remains incredibly low, the broader implications for the Milky Way as a whole are mathematically inescapable. We are currently living in a state of suspended galactic animation. Our galaxy is floating through the local group, but it is not at rest. We are locked in a fatal gravitational embrace with the Andromeda galaxy, our massive spiral neighbor. Andromeda is currently falling toward us at a speed of nearly 250,000 miles per hour. In roughly 4.5 billion years, the distance between the two galaxies will collapse, and the outer halos will begin to mesh. Astrophysicists have spent decades modeling this impending collision. The standard animations show a beautiful slow-motion dance where the two spiral structures tear each other apart. eventually settling into a single massive elliptical galaxy, often nicknamed Milkomeda. But the raw data from the Columba anomaly forces a dark revision of this future history. When Andromeda and the Milky Way finally merge, their respective supermassive black holes will inevitably sink to the center of the new galactic mass. They will enter the same decaying orbital death spiral that created the Columba wake. They will face the barrier of the final parsec. They will violently shed the surrounding stars, turning the core of the new galaxy into a desolate, empty cavity. And eventually they will collide. Because Andromeda's central black hole is significantly heavier than Sagittarius A star, the resulting merger will be highly asymmetrical. The tidal wave of gravitational energy released in the final microsecond of their union will trigger a massive recoil. The new combined singularity, holding the mass of over 100 million suns, will be struck by a kinetic kick of unfathomable power. The mathematics strongly suggest that the core of our future galaxy will not remain stable. The supermassive black hole will be violently ejected, launched out of the galactic center at millions of miles per hour. This means the ultimate destiny of our galaxy is not to become a larger, brighter, unified structure. It is to be decapitated. The Milky Way and Andromeda will merge, only to have their combined gravitational heart ripped out and fired into the freezing intergalactic void. The billions of stars left behind will suddenly find themselves orbiting a hollow center, without the massive gravitational anchor to hold the core tightly together. The newly formed galaxy will slowly loosen, its stars drifting further apart, spreading out into a diffuse, ghost-like structure. We are living in a galaxy that is fundamentally destined to be hollowed out by its own internal physics. This localized structural failure points to a much grander, far more existential timeline. The existence of these wandering singularities forces us to look past the current epoch of the universe and peer into deep time. We currently live in what astrophysicists call the stelliferous era, the age of starlight. It is an epoch defined by the burning of hydrogen, the warmth of nuclear fusion, and the illumination of the cosmos. But the stelliferous era is a fleeting, temporary phase. The universe has a finite supply of raw material. Trillions of years from now, the last clouds of interstellar gas will be exhausted. The massive blue stars will detonate into supernovas, leaving behind cold neutron stars. The yellow suns will expand, shed their outer layers, and shrink into fading white dwarfs. Finally, the faint red dwarf stars, which burn their fuel at an agonizingly slow pace, will simply run out of power and fade to black. The universe will eventually extinguish every single light source. The temperature of the cosmos will drop to absolute zero. The glowing architecture of the galaxies will vanish entirely. This is the beginning of the black hole era. In this unimaginably distant future, the only objects of significant mass left in the universe will be the singularities, the supermassive black holes that remained anchored in their dead galaxies, and the millions of rogue singularities wandering the endless freezing dark. For an eternity, these black holes will rule a completely dead universe. They will drift silently through a cosmos devoid of light, warmth, or active physics. They will encounter nothing, consume nothing, and emit nothing. They are the final inheritors of reality. The universe will become a vast, empty graveyard, patrolled by invisible leviathans of infinite density. The sheer scale of this timeline crushes human comprehension. We are a biological species that measures history in thousands of years, living on a planet that has existed for 4 billion years, within a universe that is almost 14 billion years old. But the black hole era will stretch for a duration represented by a 1 followed by 100 zeros, a span of years so incomprehensibly massive that the entire history of starlight, the entire lifespan of every galaxy ever formed, will be reduced to a microscopic flash in the opening moments of the universe's life. But even these absolute masters of gravity are not immortal. The hidden consequences of the cosmos demand that nothing is eternal, not even a singularity. The death of these rogue black holes is dictated by the subtle, microscopic mechanics of quantum physics, operating at the very edge of the event horizon. In the absolute vacuum of space, reality is never completely empty. Quantum fields constantly fluctuate, spontaneously generating pairs of virtual particles. A particle and an antiparticle flash into existence, instantly collide, and annihilate each other in a fraction of a microsecond. This bubbling quantum foam happens everywhere, constantly. When this quantum fluctuation occurs exactly on the razor-thin boundary of a black hole's event horizon, the extreme gravity violently disrupts the process. Before the two virtual particles can annihilate, the immense tidal forces tear them apart. One particle is dragged across the event horizon, falling forever into the singularity. The other particle, having narrowly escaped the fatal pull, is forcefully ejected into deep space. But the laws of thermodynamics demand that energy cannot be created from nothing. To fire this escaping particle into the void, the black hole must pay a physical price. It must surrender an infinitesimal fraction of its own mass to provide the energy for the particle's escape. This process, known as Hawking radiation, means that black holes are not perfectly sealed vaults. They are slowly, agonizingly bleeding their mass into the freezing vacuum. It is an evaporation process of incomprehensible slowness. For a supermassive black hole weighing 20 million suns, the amount of mass lost to Hawking radiation in a given century is mathematically indistinguishable from zero. But against the backdrop of deep time, against a calendar of trillions upon trillions of years, this microscopic leakage becomes a fatal hemorrhage. As the wandering black hole slowly evaporates, shedding particle by agonizing particle, its mass begins to drop. And as its mass drops, its gravitational grip on the event horizon weakens ever so slightly. This weakening allows more particles to escape, which accelerates the mass loss. The mathematics reveal a merciless truth. The smaller the black hole, the hotter it burns, accelerating its own evaporation into the void. A supermassive black hole will spend an eternity remaining utterly cold and dark, but as it finally shrinks down to the mass of an asteroid, its temperature begins to rise. It begins to glow with a faint ghostly thermal radiation. As it shrinks to the size of a mountain, the evaporation accelerates exponentially. The singularity becomes a blinding, white-hot sphere of compressed energy, violently boiling away its remaining mass. The rogue black hole, having spent an eternity prowling the dead universe in absolute silence and darkness, finally betrays its position. But there will be absolutely no one left to witness it. In its final microscopic moments, as the last of its mass evaporates, the singularity detonates. It unleashes a brilliant, catastrophic flash of high-energy gamma rays, a silent explosion tearing through a dead, empty universe. And then, the geometry of space-time simply flattens out. The infinite density unravels. The black hole ceases to exist, leaving nothing behind but a faint ripple of radiation fading into the absolute, freezing zero of the void. This is the ultimate hidden consequence of the anomaly we see burning through the Columba constellation. It is not just an astrophysical curiosity or a glitch in galactic orbital mechanics. It is a grim physical preview of the end of all things. By tracking this invisible mass, we are looking directly at the mechanics that will dismantle the galaxies, empty the cosmos of light, and eventually consume themselves in the deep, silent future. The universe is not a nurturing environment designed to sustain complexity or harbor life. It is an aggressively hostile, fundamentally unbalanced machine, currently engaged in a slow-motion, irreversible process of dismantling its own architecture. The rogue black holes are simply the heaviest gears in this grinding mechanism, silently carving their way through the dark, waiting for the lights to finally go out. The human mind is desperate to impose a narrative upon the cosmos. We look at the scattered light of the night sky, and we draw lines between the stars, inventing constellations, myths, and destinies. We build magnificent instruments of glass and beryllium to peer into the deep past, quietly hoping to find some underlying architecture that makes sense of our existence. We want the universe to be a grand theater, a place where consciousness matters, where biology is the ultimate culmination of a 13 billion-year process. We observe the cosmos through a narrow, privileged window of time, a brief period where the universe is warm enough to sustain life, but old enough to have forged the heavy elements necessary for our blood and bones. But the raw, unedited telemetry from the outer halo offers no such comfort. It strips away our localized arrogance and presents a reality that is fundamentally incompatible with the human ego. The wandering singularity tearing through the Columba constellation is not a cosmic tragedy. It is not an anomaly of nature acting out of sequence. It is simply the universe operating at its baseline. It is a machine of pure, unthinking physics, utterly devoid of malice and completely empty of purpose. And that is precisely what makes it so profoundly terrifying. If the universe were hostile, if it actively sought our destruction, it would imply that we hold some significance. It would imply that we are worthy of being targeted. But the physics of the final parsec, the catastrophic recoil, and the silent journey of a 20 million solar mass ghost through the intergalactic void demonstrate something far more chilling. The universe is entirely indifferent. We measure our legacy in the structures we build. We carve names into stone, we encode our histories into digital archives, and we launch golden records into the heliosphere, desperate to leave a permanent mark. We measure time in generations, in the rise and fall of empires, believing that the arc of history is long and meaningful. But to the mechanics of the cosmos, permanence is a mathematical impossibility. The very concept of a lasting legacy is a biological delusion. If a gravitational anchor holding the mass of 20 million suns, a structure so heavy it dictates the orbital mechanics of an entire galaxy, can be violently unmoored and discarded into the dark, the fragile chemical reactions we call life are less than nothing. Our entire history, from the first spark of fire to the launch of our orbital telescopes, has occurred in a microscopic fraction of a cosmic second. We are entirely insulated from the true violence of the universe by the temporary stability of our solar system. We live in a brief, quiet, interglacial period of cosmic weather, mistakenly believing that the calm will last forever. But the wake of burning plasma in the galactic halo is a violent reminder that the universe is actively dismantling itself. The engines of creation are also the engines of absolute erasure. Consider the perspective of the rogue black hole. As it hurtles through the freezing vacuum at 4 million miles per hour, it carries no memory of the galaxy that birthed it. It holds no record of the stars it stripped away during the long, agonizing decay of its binary orbit. It is a perfect sphere of absolute oblivion. Anything that crosses its event horizon, whether it is a stray atom of hydrogen, a burning sun, or an entire civilization, is immediately crushed out of the observable universe. The information is permanently deleted from the fabric of reality. The singularity does not process its victims. It merely adds their mass to its own invisible weight and continues its blind, ballistic trajectory through the dark. This is the ultimate trajectory of all matter. The wandering giants are not just rogue entities, they are the final inheritors of the cosmos. As the era of starlight collapses, as the last stars run out of fuel and fade into dead embers, the universe will be handed over to the void. The structures we admire today, the sweeping spiral arms of galaxies, the brilliant nurseries of newborn stars, the planetary systems teeming with chemical potential, are simply temporary configurations of matter waiting to be broken down. The universe is marching inevitably toward a state of maximum entropy, a state of perfect, unchanging equilibrium. When the black hole era finally arrives, the concept of time will become functionally obsolete. Time requires events to measure its passing. It requires movement, heat, and change. But in a universe populated only by invisible, freezing singularities, drifting through an endless vacuum, nothing will happen. The distance between the rogue black holes will expand infinitely, as the universe stretches itself apart, ensuring they never intersect, never collide, and never generate another spark of light. They will remain isolated in their own microscopic pockets of warped space, slowly bleeding away their mass through the agonizing crawl of quantum evaporation. And when the final singularity eventually boils away into a faint, useless flash of radiation, there will be no new beginning. There will be no rebirth of stars or galaxies. The long, violent history of the cosmos will end in absolute stillness. The darkness will be complete, unbroken, and eternal. We are merely temporary witnesses to a machine that is slowly tearing itself apart. There is no grand design, no final destination, and no memory of our existence waiting at the end of the timeline. We are floating in the dark, watching the lights go out.